Hey guys, this is lesson 6, methods for multiplying decimals. We're going to skip over 6.1 and go straight into 6.2, using properties of numbers to reason about multiplication. Elena and Noah used different methods to compute 23 hundredths times 1 5/10, or 0.23 times 1.5. Both computations are correct, they just did them differently. So let's look at Elena's. So she did 0.23 times 100 to make it a whole number. Then she did 1.5 times 10 to make it a whole number. Then she multiplied 23 times 15 to get 345. But because she made it bigger by 100 and then bigger by 10, she then had to divide by, well, what's 100 times 10? 1,000. So because she grew to make this bigger and make this bigger, she then had to ungrow or get back smaller by 1,000, which is 0.345. Then Noah's method is he changes to a fraction. So this is 23 hundredths, so 23 hundredths. This is 1 5/10, or 15 tenths. And then he multiplied 23 over 100 times 15 over 10 and got 345, because 23 times 15 is 345, and 100 times 10 is 1,000. And to rewrite this fraction as a decimal, 345 thousandths is written like this. So this is Elena's method and Noah's method. Both are correct. So now that we've looked through this, which method makes more sense to you and why? So if you like Elena's method, you can always use it. If you like Noah's method, you can use it. I personally liked Noah's better. So Ms. Hooks, I'm choosing Noah. I like the fractions. I'm really good with fractions. So Ms. Hooks likes Noah. And the reason why is because I'm good with fractions. Now, you don't have to write that. You can write down your own answer. So you write down what you think. So what might Elena do to compute 16 hundredths times 3 hundredths? What might Noah do to compute 16 hundredths times 3 hundredths? Will the two methods result in the same value? So let's practice what they did, and we can practice that over here. So we're going to take 16 hundredths times 3 hundredths. And Elena's method was she tried to make them whole numbers. So to make this a whole number, we have to multiply by 100, so times 100. So 0.16 times 100 gives me 16. And then make this 100, so multiply times 10 times 100. So multiply this times 100 to make it a nice whole number of 3. Then she did 16 times 3, and that gave her 48. But then we have to take 48 and we have to divide by, well, if we multiply by 100 and by 100, we have to divide by 10,000, because 100 times 100 is 10,000. And then that's going to move the decimal 5 places, because, well, 1 place, 2 place, 3 place, 4 places, excuse me. So 48 and then 1, 2, 3, 4. So 0.0048, 48 10,000ths. And then Noah's version, again, we're going to try it over here. We're going to do his version where he writes it as a writes it as a fraction. So this is 16 hundredths times 3 hundredths. Then he multiplied his whole number, his numerator, 16 times 3, which is really what Elena did over here. So 16 times 3 is 48. And then 100 times 100, oh, we did that over here. 100 times 100 is 10,000. So it gives us 10,000. And then we know to rewrite 48 over 10,000 is 48 10,000ths. So both methods work. If you like Elena's method, use it. If you like Noah's method, use it. Now what we're going to do is we're going to use this problem down here. Compute each product using the equation. So if we already know that 21 times 47 is 987, then what do we know about fractions, decimals, and place values to help us answer this? So we're going to excuse this.
Nancy, please report to the auditorium. Miss Nancy, please report to the auditorium.
Sorry about that. So we're going to use this information to help us answer these 3 questions. So if I know that it's already 987, and I know that I am going to make this out of 10 and out of 10, So that's one place value. That's one place value. What I can do is I can take the 987 and put it over 10 times 10 is 100, which gives me 9.87. Or I can take the 987 and move, since I moved once twice, I can move it once twice, and that still gives me 9.87. So both of these methods work. You could have written it as 21 over 10 times 47 over 10, and that's how you get the 987 over 100. All right, same thing here. I'm still using 21 and 47, but now my decimal values are a little different. So this is 21 out of 1 times 47 out of 1,000, which gives me 987 out of wait a second. Why is that not working? Tens, hundreds, thousands. Oh, sorry. Yep, this is fine. So then this is 987 over 1,000, which is now going to be 0.987. So the answer to this first one was 9.87. The answer to this one is 0.987. You could have also just done the moving the decimal to the left. So 987, and you have 1, 2, 3 decimal places, 1, 2, 3, and that still gives you 987. So that's just that's probably the method that your teacher taught you last year was the second one. This one might be new to you. All right, this last one, this is 21 over 1,000 times 47 over 10, and that still gives me 987 because I know that from here, over 10,000, which is 0.0987, so that's one way to do it. Or you could have just gotten the 987 and then saw that it's 1, 2, 3, 4 decimal places. So 1, 2, 3, 4 decimal places, which still gives you the 0.0987. Okay, so those are just different ways that you could have done this problem.
All staff that is in their wacky tacky attire, please meet in the 7th grade hallway. All staff in your tacky attire, meet in the 7th grade hallway.
Okay, so 6.3, using area diagrams to reason about multiplication. Use the diagram, or in the diagram, the side length of each square is 1/10 unit. Explain why the area of each square is not 1/10 unit. Area is length times width. So I know that 1/10 times 1/10 can be rewritten like this. And 1/10 times 1/10 is actually 1/100th, which is 0.01. So I know that this times this is 0.01, and so is this one, and so is this one, and so is this one. All of them are 1/100th, so I'm just going to write that over and over again. And then if I want to find the area of this whole thing, I can just add all these together. So add all 8 of the little squares. 0.01 plus 0.01 plus 0.01 ... And I'm going to do that 8 times, and I get 8/100ths. Or I could have taken this and multiplied times 8 and still gotten the 8/100ths. Okay, and then explain how the diagram shows the equation. So the side length, so the height of 0.1 plus 0.1 equals the 0.2, and then the width of 0.1 plus 0.1 plus 0.1 plus 0.1 equals 0.4. So this shows 0.1, which is 0.2, and this shows 0.1, 0.1, 0.1, 0.1, which is 0.4. So that's 0.2 times 0.4, or 2/10 times 4/10. And 2/10 times 4/10 is 0.8, or 0.08, so 8/100ths. All right, question 2. Label the squares with their side length so that the area of the rectangle represents a 40 by 20. So that would mean that this would be 10 and 10, because 10 plus 10 is 20, and then 10, 10, 10, and 10. And then so the 1 square right here would be 100, and that means the rest of them are also 100, because 10 times 10 is 100, 10 times 10 is 100, 10 times 10 is 100, and then same thing here, 10 times 10, 100. And I'm just going to keep repeating that. And so what is the area of each square? 100. Use the squares to help you find 40 times 20, explain. So 100, 200, 300, 400, 500, 600, 700, 800. Because 100 written 8 times. All right, last one. We're going to label the squares with silent so that the area of the rectangle represents 4 hundredths times 2 hundredths. So we know this is 0.01, and this is 0.01, and this is 0.01. All of them are the same. So 1 100th times 1 100th. So 1 100th times 1 100th equals 1 10,000th. And the way you're going to write that as a decimal is 0.001. So I'm going to write mine sideways, 0.0001, 0.0001, 0001, 0001. And then I'm just going to keep doing that until I fill in all my boxes because they all have the same area. Okay. And then if I add all those together, I have 8 10,000ths. So 8 10,000ths, which is 0.000. All right, so there's your lesson on lesson 6, methods for multiplying decimals, and then you're going to go ahead and complete your practice problems. If you need a little bit more support, read the lesson summary or do your Khan Academy. The answers for your lesson 6 practice problems are on my website. If you have any questions that can't be answered with the Khan Academy videos or the answer key, please ask Miss Ashley or Miss Hartman for any help. They are right across the hall. All right, I hope you guys have a great afternoon, and I will see you guys when we get back from break.